I'm Tobias Munk. I am from Copenhagen, hence the name. I do iOS development and design, and yeah, I live in the nice city of Copenhagen of Denmark. It's really hot today, so yeah. But let's get started. So learning functional reactive programming. I think it would be easiest if we skip the reactive part, right? Now, I'll introduce some things that aren't reactive, and then we'll get to the reactive part in the end. I've learned this type of programming not that long ago, so this is kind of my journey from not knowing anything about it and then using Swift to learn some functional stuff, and then in the end I learned some reactive stuff and then tried to combine it. So I'll kind of take you along on the journey that I had when I tried to learn this paradigm. So Swift has some built-in functions that are, as we like to call them, functional. So for instance, on a collection, so something that could be a dictionary or an array, there is some functions. So here you can see we have filter, we have reduce, and we have map. So if we start with the first one, you can see we have an array with 4 numbers, and then we apply a filter to it, and for this filter function, we give a small closure where we say, do we want to keep this element in the array or don't we? So the even function basically takes the even numbers and says, well, this is true, so that means that the filter function will include that element. So as you can see, 2 and 4 are included, and 1 and 3 are filtered out by this function. So it's fairly simple, and can be quite useful for doing things in line, which is kind of like a common theme for all these functions that are very good. They're very good in line. So next up is an example of reduce function. So what I've implemented here is something that basically takes the sum of the numbers. The reduce function has an initial parameter, which I here has set to 0, because then we have a sum starting from 0. And then the closure that we give to the reduce function is something that takes 2 values. It takes the current value we have, and then we are adding a new one. So the $0 sign is something that's is a shorthand for the first parameter given to the closure, and the plus, and then we plus the $1 sign, which is representing the current value as we are iterating through the array. This can be quite useful, and as you can see, this is here used to implement a sum function. So if you do the math, then 1 plus 2 plus 3 plus 4 will sum up to be 10. Then we have a map function on the collection, and now we're beginning to get into some territory that is I think is quite interesting and can be quite useful, as well as very powerful in terms of being very clear about what our code is actually doing. So the map is basically iterating over all the elements in the collection. Here we have again the same array, and then we apply an ordinal function to each element. So you can see that the return of this is strings that are has the ordinal added to the number. So you have first and second and third and fourth. So the transformation that we are applying to these array is quite easily done using this map function. So it's really powerful, and I really use it all over if you ever happen to end up in my code. So as I said, the collections could both be arrays, they could also be dictionaries. So an example here, we have a dictionary with 2 key value pairs, and then the map function is supplied with 2 parameters. So instead of before where we only had 1 parameter, here we have both the key and the value. So the key value paired are supplied to the closure for the math function. So you can see the $0 is the key and the $1 is the value. And yeah, here we do some transformation while we're doing it, plus we're adding the string together. So in quite a short syntax, we actually have something that does quite a powerful transformation, but it's also something that is actually quite descriptive in terms of what we want to do to the supplied dictionary. So collection also has other functions. I don't think I have all of them in my slides, but here are 3 other that I want us to look at before going on to other stuff than just collection. So here we have a function called flatten. The collection here is something that has a nested array. So we have this array including 2 arrays. And the flatten function basically takes them and flats it out into a single array that is similar to the arrays that we had previously. And then in this example, I've shown it with a transform afterwards, where we map the numbers into the ordinals. And as you can see in the output, we have an array that doesn't have these nested arrays inside them. So if you have a tree structure of something in your collection, then you can use the flatten to flatten them. I think it's quite logic, but yeah, it's just to show different types of functions that you can use, and of course you could also make some of these yourself if there's something that is missing. So the pattern of having this function that you apply to collections is quite powerful. The next one up is something called a flat map. And the flat map is not actually something that first flattens something and then maps it. Actually, the flat map is something that tries to handle the fact that we have optionals in our code. If you have something that returns an optional, so here you can see the even ordinal function is something that takes a number, and then if the number is even, then it returns the ordinal. And that means that sometimes this will return nil, and sometimes it will return a value. So basically, it returns optionals that can either be the string or it's an empty optional. And what the flat map does is actually it says, okay, but if the thing that you are giving me, so the closure that we're giving to the flat map, if it's something that for an element in the array returns a nil, then I'll discard it. Then I won't include it. So what it basically does, it filters out the nil versions of the optionals. Actually, I have a slide here that shows what it does in a bit more detail. So imagine that we're chaining 3 functions together, first a map, then a filter, and then a map. And then we basically have what the flat map does for us. So as you can see, the first map function is doing the transform. And since even ordinal is something that returns optionals, then in the next line, when we do the filtering, we say, okay, we only want to keep the elements in the array that are non-optional. And then in the end, because we have optionals, then we need to unwrap them. And I know this is not a way to do it, but this is basically what's... I need to explain. So usually we don't want to use the bang character for doing force unwrapping, because we could crash. But this is just a way of showing you how the flat map actually works. So this does perfectly the same as the flat map function does. And then finally, for the collection, we have a split function. It's quite simple. It just takes the it just takes a closure that says, okay, do you want to split at this point? So it walks through the array, and then it says, okay, for this element in the array, do you want to split the array? And as you can see here, we supplied with something that says, well, if it's an even number, then we do want to split it. And the result is a bit tricky, but actually it's just, think of it as two arrays inside an array, where you have the first array something containing the elements that were before the first split, which is for the number 2, because that's our first even number. And then the second array is something that is contains the next one. So you can see that the split function is splitting the array in 2 and 4 at the number 2 and the number 4, so at indexes 1 and 3. And then we have this return results. The reason for array slices is it's an implementation detail in Swift, I think, or it's actually there for performance, but we don't need to get into that. We can talk about it after the talk if you want to hear more about it. Okay, so those were some functions that could be applied to collections. But one thing that was actually quite interesting to me was when I found out that, well, optionals also have map and flat map. And I thought, well, that's kind of strange. What do they do? So let's have a look. The optionals in Swift are something that, as you know, it is, or as you probably know, is that it contains either a value or it doesn't contain a value. And the map here is something that says, well, if there is a value inside it, then do this transform on it. And of course, if there is no value inside it, it won't apply the transform. So as you can see here in this example, the even ordinal for a 2, for the number 2, will actually return the string that says second. And then in the transform, we will apply the bank character. And then in the result is an optional string. If we do this for the number 1, then we will not have, or we will have an optional with a nil value, and therefore the transform is not applied, and we just get the nil value directly in the optional. So what this is you have a function that is only applied if there is results, which is a quite interesting way of doing code. We always do this, but typically this is done using if statements or doing other things where we try to say, okay, only go down this code path if something is there. But in the functional paradigm, we try to use a different way of writing the same thing, and this is an example of that. You could imagine that you before that, when you, as I said, that you can use this if syntax for taking out the value of the optional. So you can see the way we do it in Swift is that we have this if lets, and then we say, well, the value should be equals to foo, and if foo actually contains a value, then value is so we unwrap the optional this way. You might have seen this doing Swift code, and then we can do a transform on the value, and then in the else part of the if statement, then we basically say, well, just return a string that has a hyphen or an n dash or something. And then you can see the down below is actually a way that I have started to write the same code in another way. So it's basically just a refactor of the top parts. And what you can see here is that we have a map on the foo. And as I said before, the map is only applied if the foo actually contains a value. And then we can apply this transform that is the ordinal function. And then we have a kind of iffy, strange character which is this double question mark. And what it is that if the value to the left of the double question mark is an optional with a value of nil, which would be the case if foo is nil, then you should return the value to the right of the double question mark. So the two code examples here are doing exactly the same thing. You could argue that the readability of the top one is a little bit better, but the bottom one is kind of something you get used to using when you begin using this map functions. So it should be used carefully, I think, particularly depending on on the use cases of the code base and the people who are working on it. But I quite like the way of doing this map and then this double question mark. I can see in the chat that someone is calling that the ternary operator. I don't know if like the ternary is usually the question mark and then colon, but this is kind of like the same thing. It's just working on optionals. So yeah, it's quite interesting paradigm. Let's skip ahead and then go to the flat map on the optional. As I said earlier, that when we have this map, it only applies the transformation if there is a value inside the variable. So for foo, and then imagine that that the transformation that we want to do is also something that can return an optional. And then in that case, you would have something that the result type of the entire line is an optional of an optional of a string. So in this case, you have the optional second. And that can be something that you would use, but it might not be something that you would actually want in your code. You only care if there is a value or if there isn't. You don't care if like you have these multiple optionals. So the flat map function. The flat map function is something that, as we saw earlier, for the collections, filters out things that are that is an optional without a value. So as you can see here, the result of this line with the foo.flatmap and then applying the even ordinal transform, and then you can see that the result of that is just a single optional of the string second. And the way that, or I should say that the concept of the iterative or like the multiple optionals not being something of value of us, we only care if there is an optional or not, is something that we'll see more of in the following slides. So yeah, as my slide states, it's flat map allows for failable transforms and it handles them more gracefully than the map. Yeah. Okay, so just for a single odd functional function, we have the zip function. It takes two arrays and then it zips them together. So it's just like a zipper, or you could call it the merge function. It takes two arrays of the same length and then combines them together into to something where you have the two values standing as tuples. So so the tuple is something where you have two values. So you have a tuple where there are two values in. The first value is from the first array, and the second value is from the second array. So in this case, you would, after the zip function, you would have 4 tuples containing 2 strings each. And then you can see here that I'm applying the .map function to this zipped array, and then I'm taking the tuple and just adding the two values in the tuple together. So here you can see we have first bang, second question mark, third reverse bang, and then fourth reverse question mark. I don't use this function very much. It's quite it has quite a specific use case, but when you use it, it's just so much better than trying to do this yourself using for loops or other things like that. So yeah, that's quite a good one. I like using it. Okay, so I don't know if you saw that I changed the slides there. There is a very small distinction that I want to highlight. So if I just go back a second, you can see the function that I'm applying to the map. In this case, as you can see here on the slides, is something where I'm giving it a closure that has the shorthand syntax for the values given to the closure. But actually, the map function is just something that takes a function that has 2 values going into it and then returns 1 value. And the plus operator is something that does just that. It takes a left-hand side and a right-hand side arguments, and then it returns the sum of the two. So this is it's a very short way of writing something that is actually quite complex, but I actually think that when you look at the code, it's very descriptive of what it is that you want to do. So of course, coming from Objective-C as I do, this is something that you need to get used to, but I quite like the descriptive syntax that it results in, as you can see here. Okay, now we'll try to see how can we use some of this way of doing functional stuff on collections or on optionals, and see how can we use this on another type of class or value. And for this exercise, so to speak, we will look at the results type, which is a specific type. I'll get into it in 2 seconds, and then we'll see, okay, how could we actually implement a flat map on this one to be able to do things that are similar to what we've seen on the previous slides. Because flat map is something that is quite much used, and a concept that is used quite a lot of places in functional reactive programming. So it's interesting to see how could we actually implement this. So let's get to it. So here you can see how the result is defined. It's a generic enum. So you have the result of type T, and then you have 2 cases. So you have the success case, which takes, or you have the success case which what do you call it? It includes the number or the value of T, of type T, and then you have the failure case, which basically has an error that is the error protocol. The error protocol is just a type for errors in Swift. As you might know from optionals, this is actually quite similar to that. So if we just take a look at the implementation of optional, you can see that optional is also something that is of generic type T, and then there are 2 cases as well. You have the sum case, which is similar to the success case we saw just before. There is that has this the value of type T, and then you have the non case. So for the result, you just have a failure case instead of the non case, which actually includes some information about why am I not in the success case. And this can be quite useful. For instance, if you have a function that parses JSON and then it fails at it, instead of just returning an object for, let's say, you have something that parses something in JSON to a car object, then you don't know why it did it, because the function just returns an optional, and if the parsing fails, you just get a null back. But in the result case, you get a failure case back, which has the error included in it. So it's a quite you can look at it as like an optional 2.0 or something. It's quite interesting. So here we have an example of how we could implement flat map on the result type. This is quite a lot of code to put on the screen, and I'm sorry for that. Don't worry, there will be more screens with a lot more code. But let's try to take a quick look at it. So I think I can point at the screen to help explain what it is that I want to show. So we have this flat map on the result type, and it's something that is a generic function. So it's it has a new we're coming from an extension on result of type T, and then the flat map is something that has something to do with this generic of type U. So you can see here we give the flat map is something that it takes a function that has T as an input, and then it returns a result of type U. So it's a transform from T into something of type U, but it's encapsulated in a result. So that means that the transform is something that can fail. And if it fails, we will, as we saw before, it will be a result that has the error case, which includes the error inside it. And for reasons that might become obvious later, we also return this result from this function. So we can see here inside this flat map function, we are switching over self, so the result that we're currently applying this transform to. If it's a success, if we're in the success case for this result, we will return the value T, but only after we have applied this transformation to it. And for the failure case, we just propagate through the error. So what you can see here is that the reason for returning the result for this flat map is that then you could chain flat maps together. So we have, you apply a transform, and then you return the result, and then you can apply a new transform to that result. But every time we only apply the transform if it's actually in the success case. The minute that we go into the failure case, then the failure case will just propagate through. Just to give you a short example of this. So imagine that we have a function that reads a file from a string and then converts it into data. This might fail, and that's why we're using the results of type data. And we do the same thing for to JSON and to car. And all of these, you can see the output of the previous one lines up with the input for the next one. So the output of read file is data, and the input of to JSON is data. And the example that you can see here below is something where you have two flat maps. So you have the read file operation, and then you flat map the to JSON function, and then you flat map the to car function. So what this means is that when you read the file, let's say it succeeds, then you flat map on it. And as we saw before, when you flat map on the result, the way we implemented it, then we apply the transform to the value that is in the result, in the success of this results. And then let's say that the to JSON function fails and we give an error. Then the next flat map function that was supposed to convert this dictionary into a car object will actually not do it. It will just propagate through the error. So again, as I said earlier, this is quite a powerful way of saying, okay, only do these code paths if there is not an error, and if there is an error, then you should just propagate it through, and then you can handle it on the variable user result in the end. Well, quite a lot of times we want to do this asynchronously. So we want to apply a function to something, apply a transform to something. You might want to go out to network, or you want to go to the disk. So for instance, for the read file, we actually go to disk, so this is done in the background, and then we return later on. And this is an implementation showing how you can we can implement the flat map on result that does this asynchronously. And again, here we have a bit more dense syntax, but what it basically is that instead of having results in and out for this flat map, we have completion handlers that provide the result to this completion handler. So this way we can nest things. What the flat map does actually is that we can change things that return things in an asynchronous manner. So I think I'll just go to the next slide, and then you can see an example of how this would actually look like. So now you can see that the read file and the to JSON and the to car functions, they all take this return like a completion block or a completion handler for how to handle the result of the operation. And the 3 lines you can see in the bottom, we do the exact same thing as we did before with the synchronous tasks, but here it's actually done asynchronously. So you might wonder then, well, what is user result? This is not like, if the code is asynchronous, what does this mean for the user results? It means that the user result is also a completion handler. So that's something that also has to be handled. So you can see here that we can flat map on the end of this chain of reading the car, changing something. Okay, I have a spelling here. I can see the torsion stuff. I don't know why that's in there. So we go from reading the file and to going to JSON and then to the to car. And then in the end, we flat map and say, okay, we actually want to put the car name into a text label. But we only do this for the success case. If there is an alert, then we could probably show it to the user as an alert or do something else. And this error could both be from read file, from the to JSON, or the to car function. So this is quite powerful. I think I'm getting quite along in the talk, or a bit too slow along here in the talk, actually. So let's look at the reactive part of this, and then we can get to the question very soon. In the reactive world, doing asynchronous results as returns is something that can be thought of as futures, promises, or often is also called observable signal streams, channels, or pipes. I'm just showing you all these words because if you use a functional reactive programming framework of some type, they might use these different names, but they all try to encapsulate the same way of dealing with things. I'll just go one slide back. One important thing to know about observables compared to an asynchronous result is that typically you can call the completion handler multiple times. So that means the thing that we saw before with the read file from disk, let's say that the file changes on disk and the read file function automatically listens to it and then returns again. So you will have something that continuously gives you files read from disk, and then you also continuously apply the flat maps onto these. So you convert it to JSON, you convert it into a car, and then you continuously also update the label for the car. So this is quite a powerful way of channeling your data from one point to another without having states anywhere in the chain. You just have, or you can say the state is encapsulated inside these observables, so these streams, channels, pipes, whatever you want to call them. So here there is an implementation of something that you could call an observable. Some things to note here is that you can see we have a value which is basically the latest value that has been in this observable. So let's say that you read from disk 3 times because the file updated, then the latest read will be the thing that is in the value. Then you have observers, which is basically who are listening to me, like who are the ones that wants to be called back if something is happening to me. And then you have these subscribers where people become observers, and then you have this update function, which is something where, let's say when you call, so when you call it is something that's is applied to the observable. You store the result in the value, and then for each of the observers, you actually go through them and call this completion handler for each of them with the new results. And actually, you can see here the for each function is actually also a functional thing that is available in Swift. Yeah. Okay. So here is an implementation of how observable would be done synchronous. This is very similar to the one that we saw for result. I will not go into the details of how it's implemented. You can look at the slides afterwards and see if it's something that you can understand. I find it quite difficult to actually understand this, but yeah, you just have to go through it multiple times to get an understanding of it. But basically, what we do is we can do flat maps on observables just as we did before with results. So okay, let me skip back a slide. What you can see here, this is something that is synchronous, and then when I go slide forward to this one, this is asynchronous. So just as for the result type we had earlier, we now have a completion block that is supplied to the function instead of just the results. So we have something that takes that gives a result that returns the void. That's what you see here. Okay. So let's jump ahead and see what some of the things that you could do with an observable. I will not show the implementation of this, but this is just to show that you can do different things with an observable. So all these different things that we have shown on all the slides, you could possibly do on an observable. So we have flat maps, synchronous, asynchronous, and we have flat maps that works on an observable to an observable or something that is from a result. So say that you have something from a function that doesn't use observables, you can still upgrade it. You can still change to it and then upgrade it to being an observable and then change things to the observable. You can also see here we have some bonus stuff for map and flat map. The flat map one is something that takes function that has the Swift type of throws, which is Swift's way of handling the Swift native way of handling errors, and we can upgrade it to an observable as well. And also, as we saw earlier, we can do filters, we could do merges, which is similar to what we saw for zip. So you can imagine you have multiple streams of data coming in, and you always want to observe both of them together, and only when, let's say that one of them changes, then you want to do something. So you have 2 buttons that can flip a switch or something, and then you only want to do something when both of them are positive. You could do that using merge and filter functions. So just these are I have 2 slides left, so just go through them quickly and then we can take some questions. When you create an observable, you can see it here, we have a button, we have an observable, which is a type bool, and then when this button becomes selected, then we call the observable with the update method, and this pattern is very simple to how we would do if we had delegates listening to the button. The good thing with observables is that you can have multiple people's or multiple observers for this button, and not only with delegates where you can only have 1 delegate at a time. It might be good or it might be bad, but it's just something to note in terms of what it can do. And then when we want to listen to this, here we have implemented the button inside a view controller, and then in the view did load we set this up and say, well, the button's observable, I want to filter it, so only when it's selected I want to go through here. And then in the last flat map I play a sound tap whenever this happens. So whenever the button becomes selected, where the selected then has a value of true, then the sound would play. You could imagine doing all different kinds of things like this. Yeah. So this was basically it. I have some slides here with some links. I'll share the PDF afterwards. So if you want to go in and see videos or read about it, then you can see it. There's also a nice book from a big CIO that is mainly about the functional part, but it's quite good as well. It's really thorough. So that was functional reactive programming. Yeah, I think we'll just do some questions now. So I can see here. Oh, wait a minute. I'll just. I think I'll leave here. So now you can see me, and I can not see you, but that's okay. So there's a question here. I don't know if you heard about promises, which is a concept that basically lets you manipulate asynchronous code, like if it was synchronous. It became a part of the standard ECMAScripts with deferred closures and other keywords in Swift 3. Do you think promises will become standard in Swift? Okay, so promises is very similar to what I showed for asynchronous results. It's very much the same thing. Details are only the different, or how you, yeah. So it's just a matter of what terminology we use for it. Promises is the same thing as, yeah, promises or futures are the same thing as asynchronous results. In terms of if it becomes a standard part of Swift, I hope so. I hope that there will be some things that lets us having these. I think it's maybe C# has this wait command when you can do different asynchronous things, and then you say, okay, I only want to continue from this point if all of the previous asynchronous tasks are done, which is a quite nice way of merging different things together. I currently, if I want to use something functional reactive programming style, I use a framework called Interstellar, which is very lightweight and very simple. Some of the code examples I showed is very much inspired by way that is implemented. And it's light enough so that it's just something that I can understand and I want to use in my projects. So for instance, when Swift 3 came out, 3.0 came out, I could update Interstellar myself and use it in my code without having to wait for a branch to be updated for it and support it, which is quite nice. Okay, so not sure if you gave it already, but what is your Twitter? Let me just go and do this here. So now you should be able to see my Twitter handle, my GitHub, and my websites. I can also just type it in the chats so you can see it here. Yeah, great. So there's a question here. Were you surprised by Swift not including something like this directly in the language? I don't have that much experience with different languages and their maturity, but I think that it's something that could be interesting to be in Swift, but I think it's also very understandable that it's not something that is there yet. In my opinion, it's something that could not easily, but it's something that is better to put into a language once it's other more normal things to do are settled, and then you can say, okay, if we add it this way for the asynchronous handling of code, then it feels Swifty, as everyone says, right? So it feels native to Swift. I definitely think it's something that will be there eventually, but if it's 5 years or if it's 1 year, I don't have any clue about that. I haven't heard anything about on the mailing lists for Swift development, or so yeah, for Swift open source projects, just like people share stuff, they put in proposals. I haven't seen anything for asynchronous code yet. There's been complaints about it, but not something as an actual proposal for it. Yeah, but hopefully, or people should just go in, do proposals, and be on the mailing list if that's what you're up to. That can be quite interesting. So yeah, are there any other questions? So, question about mailing lists. Or did I answer the question about the mailing list, or do you have something? Okay, great, that's good. So apparently I already answered it. Yeah, as I said, I haven't been on the mailing list, but I follow. I think it's Jesse Squires. He has like a weekly posting of these are the things that are interesting in Swift, and so it's a nice summary of all the things that happen through the week. So. And on those ones, I haven't seen anything, but yeah. There is something here. I think Chris Eidhoff's talk about this is a little, but how do you blend FP styles in general work in FP project if that's... Okay, so how do you blend non-functional programming styles with and generally work with functional programming into projects that already have other programming styles and programmers that might not be FP savvy. I don't know how to pronounce that. Oh yeah, thanks for the Jesse Squires link, by the way. So the way that I usually combine it, I haven't found a this is the way that I want to do apps from now on. I've tried different things. I've tried to go all in with functional reactive programming and putting it into just a side project app that I'm working on, but it seems a little bit too heavy. But in general, right now, when I code normally, I use functional part of Swift all the time. It's usually code that is done inline. So instead of having a couple of nested if statements or for loops or something else, it's done much nicer in the functional programming way, I think. So I really like to use it, and you can easily use it inside functions. You don't have to use it in every view control or something, but it could be done, like for instance, in the processing layer of parsing JSON or whatever. That way I use it quite a lot. And then also part of the pure project is, what about programmers that are not all into functional programming? I saw a talk about was it? I think it was from Andy Matuszak. It's also some of the links that are in the in my slides. I'll share them later. He had a good way of talking about it. So for instance, for one of the examples that I showed you was the flat map on the optional. And I saw some people in the chat that actually reacted to this and said, "Oh, this is quite interesting," or "mind blown," or whatever. I think it's a nice way of introducing people to functional programming style of coding to show, okay, which features are native to Swift. If you're doing a Swift app, well, then I think the programmers have to, first off, they have to do some things that are Swifty, but I also think that this will become even more and more used. So if you can show something like optionals and flat maps to someone, I think they will find it interesting and something that they can learn something from. And then possibly they will continue to use it and use it in other places. Me, myself, I don't work on many projects with a lot of other people. I usually am only me or one other programmer. And then we just basically find a common ground for how do we want to do things. Because some things can be too detailed, or the syntax can just be too, yeah, becomes unreadable in the end, or it's something that when you get back to it in 3 years, Swift has changed from that. But some of these things that are shown here in these slides are very native to Swift, and I really don't think they will change or go away. It's just that it's something that we didn't have in Objective-C. Now we do have it in Swift, and I think we should learn from it and see, well, when do we use these things instead of whatever we did in Objective-C. So there is a question here: do you prefer Interstellar versus Reactive Cocoa, RX Swift, or React Kits? So as I mentioned earlier, I use Interstellar. I haven't done anything in Reactive Cocoa, RX Swift, or React Kits. I know that's quite strange when I do a talk about functional reactive programming, but this is actually because I'm trying to learn functional reactive programming, and doing talks like this helps me work through it and figure out what the details are. So far, I've only used Interstellar. I really like that the code base is very small, it's very readable, and it's easy to go in and figure out the concepts that you've seen in videos about functional reactive programming other places. And then, yeah, as I mentioned, I was able to update it to Swift 3.0 when that came out, so I didn't have to wait for a branch to be made by the original author on GitHub. And also, it's a one-man show, so my branch is something that will probably go back into the project later. So it's quite nice to have something that seems like something where you can understand all of it, not all of it, but yeah, you can at least dive down and understand what happens in the code. As for Reactive Cocoa and RX Swift, they are huge projects, and it's also a very huge dependency to add to your projects. So far I haven't used any of them in any client work or in production apps. But Interstellar is something I have on a side project that is going to be in a production app. But it's a fairly small app, but it's also just for trying things out and see, okay, if I did everything in the Interstellar way of doing it, then how would my code end up looking? But yeah, but also Swift is still changing a lot, and we're still getting used to protocols. So I think a lot of things that, well, to me looks interesting in functional reactive programming, they can also be solved natively in Swift in other ways that doesn't have to be either the way we did it in Objective-C or have to be functional reactive programming. So there's also some middle ground in terms of what Swift gives you natively, and also when Swift evolves and adds new features. Yeah, I hope that answers the question. So are there any more questions, as I think we are about to get close to the 50-minute mark, which is my cue to end the video. I hope everyone enjoyed it. Thanks very much for joining in and listening. It's new to have this chat that runs live. A few times I was kind of a bit confused about it, but yeah, it's really nice to see this chat going in. So yeah, very thankful for being able to do this talk to you. And hit me up on Twitter if you have more questions or anything. I really think it's an interesting subject and something that can improve our way of working with Swift, and at least it can improve our way of understanding how it works. So that's really good. Well, thank you for all the nice responses in the chat. That's really great. Well, see you guys. I'll end the video now. Cheers.